Hi, my name is David DiDonato. I work for Social Media Work Group in Albuquerque, New Mexico, and I thought I'd give you guys some feedback and some information on how we've been working with the BioHack boards so that you can see our process and know what we're doing. I've got a little lab set up right here. I've got a BioHack board, and we'll work through some of the different things that I've been doing, some of the problems that I've been having, as well as talk about some of the issues that we may have had programming it and what some of the strong features are. So, let's get started. So, we got our boards made by a company called Osh Park. They're based on the West Coast in America. They make nice purple circuit boards. You may have seen them before. This particular version has a few pieces left off. I've been playing around with different configurations on some of the other ones with some of the MOSFETs. So I've got a demonstration of the MOSFETs right here. This is an IRF 520 or 540. Very similar to the type that you guys are using. It's an N-channel MOSFET, and I thought I'd show you guys some of the characteristics of the gate and some of the issues that we've been having. So the 5 volts that comes out of an Arduino isn't necessarily the best thing to be driving this with. We were having some issues with the things heating up under certain loads or not working at all, depending on the loads. So one of the issues that I discussed in the paper was the gate of the MOSFET being pulled down. I thought I'd do a little bit of demonstration for that to show you what I'm talking about. So we got a circuit right here hooked up through a generic N-channel MOSFET. We can turn on a little light bulb with it, and it's hooked up to a power supply. So we've got it at 12 volts, and instead of having an Arduino hooked up, I'm just going to show you really simple with my fingers. Right now, this gate is what's called floating. It's not connected to a ground or anything, right? And if I go and I touch the power supply and the gate, I can actually turn that on with my finger. This is only my finger and the electricity in it. That can happen with things like static or just general charges, static charges that you have on your body. Now I can turn it off by pulling it to ground, right? The N-channel MOSFETs turn on when they're high, off when they're low. I can turn it back on. I can turn it back on, turn it back off. This is just with my fingers. But if I put a gate resistor that pulls, you can even see it fade down right there. That's it losing its charge. If I pull down the gate, you can now see the effect doesn't work. The pin is automatically grounded. This can come into effect when you have problems with the grounds not being as low resistance as you want. It can come into effect with things like voltage spikes, and having this nice resistor there helps pull it down to ground and keep it from turning on inadvertently. One of the other things that we were thinking would be nice would be warnings for the current or specifications or some sort of ratings printed on the BioHack board. There's no other apparent means to power it besides the barrel jack or wires that go directly up to the headers, and that can cause too much current to be flowing through this diode right here. On typical Arduino Unos, it's right next to the capacitors. It's actually just your common 1N4007. These things are only rated for 1 amp, and they protect the barrel jack. Anything going through there can burn out the diode. And we think it would be nice at the very least to put some warnings on there. Another thing that might be good is a dedicated terminal on the BioHack board itself. Having an external power input would allow the person to hook up however much the BioHack board was actually rated for on the PCB traces here. That's a lot more than this, and then the Arduino could just be powered by the VN pin coming from here. So, I also got myself a diode, one of your 1N4007s, and I thought I'd hook it up to a power supply and show exactly how hot it gets. Check it out. We can go and we can start cranking up the amperage on this diode. So, at 1 amp, it starts getting warm. Once we get up to 1.5 amps, that actually starts getting hot. And at about 2 amps to 2.5 amps is where it starts getting unwieldy and starts becoming in the territory of burning. So we think this problem could be resolved with a simple warning label, something that lets students know that after a couple amps, the Arduino board isn't going to be able to take the 12 volts through the barrel jack. We also had some issues getting the stepper motors running, and we have some recommendations for how they could be improved. So one of the first things to note is that the hardware is actually able to be placed all underneath the stepper driver. Depending on how you do it, whether you lay them side by side or in a row, you can actually put them right underneath the stepper driver. This is just a general CNC board that I got at some point a long time ago, but you can see how these manufacturers have hidden the capacitor and the pin select headers underneath. You also don't need the grounds because these guys are pulled up. So that's an extra part that could be eliminated. And more space on the board, which allows for either better and easier layout or a decreased board size, which decreases the cost. So these guys can pack this thing much more tightly, and I recommend that that be implemented on the new BioHack boards. One thing I do appreciate, one thing the programmer does appreciate, is the fact that these pins are labeled. Very convenient. Thanks. One other thing that we noticed is that the drivers burn out if there is no motor attached to them while they're being driven. We looked at the manufacturer's datasheet, and it actually said that this is a known thing that happens. So there should be some sort of a note, or at least some sort of recommendation about this in the documentation. One of the other issues that we were having was finding the documentation and figuring out which documentation was actually for what. We weren't apparently using the correct version of the BioHack boards. We ended up having the one that has the SMD parts on it manufactured. And we think that we could make some recommendations for how to maybe structure the BioHack board's GitHub repository to make it a little bit easier to use. So one of the things that we noticed was that the BioHack board was moved to the Autodesk.io or the Circuits.io platform from Autodesk. And this is a great platform. It's cool because it allows you to actually view the schematic on like an actual web browser and have it be dynamic, have it be, interactable and stuff like that. So this is cool, but the primary source of information on it still seems to be the GitHub. And we noticed that on the GitHub's BioHack board entry, this new one hasn't been added. And some of the documentation for the old one was a little bit difficult for us to understand. Going into the BioHack board's repository on GitHub, the bill of materials doesn't really mention what types of parts we need in terms of their form factors, and that led to us getting some incorrect parts. We also have a picture of the version that has the THT components right here, but we don't have any assembly pictures of the Pololu stepper driver ones. Another nice trick is adding images of the schematic and the board to GitHub. We're talking actual JPEG images or PNG images, something that lets people view the board schematics without actually having to open up Eagle. It is nice that there is a fritzing design for the BioHack board. So we're doing a little redesign of the board, and while there haven't been any major changes, we've made some aesthetic changes that we think will help make some of the usages more clear, as well as provide the user with a few extra options that they wouldn't have before. So let's take a look. We've got the schematic right here, which we think is a little bit better laid out and a little bit more indicative of what's going on. So we've got each of the different sections, each of the different features of the board, if you will, that are all in their own individual boxes and are all laid out in such a way that the user can figure out exactly what part of the circuit they're looking at and what they're doing when they're trying to figure out where the connections go. One of the things that we still haven't completed, one of the things on the to-do list, is routing the pins to the appropriate places on the board. So we've still got to do that. We've also laid out the circuit in a different way such that all of the different parts, all of the different squares in this category are actually bounded by their own separate squares on the silkscreen mask here. This allows you to go and look at what part of the circuit corresponds to where on the actual schematic. We've also gone and moved all the different configuration stuff in the capacitor for the stepper motor driver underneath the driver. This allows us to cut down on space and gives us a little bit more room on the footprint. We added the diode right here. The reason for this is because even if we want to save money by not putting on a diode, we can still just leave the diode off. If the user isn't driving an inductive load, sure, there's no reason for them to have a diode on there. Well, we just don't need to solder it on. Then, no harm, no foul. In conclusion, we appreciate the opportunity to work with you, and we're enjoying working with the BioHack Board, and we look forward to getting a new model done that will be easy to use and fun to work with.